that they may be having. So this is our ninth such session of this weekly series, and let us directly jump into the queries for this week. So the way to ask queries is through Google form, or you can put your queries in the live comments, or you can write it in email. Okay. So first we will start by taking the queries that we had received on the Google form. So let us begin, and let me share my screen. So in the last session we had taken till this 119, this was taken. So now this first query is from CH Trilok Raju. He is from Vijayawada in Andhra Pradesh, and he is an independent consultant. He is saying how to design the RCC transfer girders in 40 floors high rise building, which is having shear walls, and shear walls are starting from the typical floors and resting on transfer girder. Due to the stiffness of typical shear wall, the load is not attracted to the transfer girders. Therefore, minimum steel comes. Can the typical shear wall starting from the transfer girder be assigned with property modifiers of F22? No, so you need to give me more data in order to answer this question in a proper manner. So, more data is required. Right now, with what you have provided, I am unable to answer this question right now. Maybe if you can send some ETABS model that you have prepared or something like that for me to better answer this question. Okay. Okay. Next question is from Mr. Harish Acharya from Mangaluru, and he is asking which is the best software for analysis and design of steel structures. So usually if you see, practicing engineers mainly follow or mainly use rather STAD, ETABS. These are the two commonly used softwares by practicing engineers. So out of them, if you ask, overall ETABS is a better software, be it for steel design or be it for RCC design. So just a minute. Just give me a minute. Yeah, so the question is which is uh, better. So in the audience, if someone can answer, which software are they using for steel design, if at all they are involved in steel design? So I would say, because overall, if you see, ETABS is a better software than STAD in most of the features, in the input features, in the modeling features, in the output features, especially for building like structures. ETABS is a much better software as compared to STAD. So even for steel design, the modules that are available in ETABS are better than STAD for steel design. But there are a few issues in ETABS when it comes to use of IS 800 2007. So there are some specific issues in ETABS related to this code, which STAT does not have. So those issues are, if I could list down some issues over there, one issue is that ETABS does not consider slender webs properly. So the sections having slender web uh, are not considered properly in ETABS as the code wants you to consider it. The second problem is that if you have made a section using section designer in ETABS does not consider its warping constant or CW. So it takes the CW as 0, and that is a problem in ETABS, which is not there in STAD. If you bring a section from section wizard instead, you don't face this problem. But you see this problem in ETABS. Another problem in ETABS related to steel design is that it considers the flexural torsional buckling limit state while calculating the compression strength of a member. It calculates the flexural torsional buckling strength while calculating the compression capacity of member. So that again is not mandated in the Indian code as of now. So that is again a problem ETABS has. This problem again you won't find in a software like STAD. So there are these issues which ETABS has when it comes to steel design, especially with the IS 800 2007 code. But other than that, if you ask me, ETABS is a better software than STAD because of its other features. But when it comes to AISC, let's say AISC 360 or 22, then I think ETABS is, I mean, because it's an American software, because it's an American code, it has taken care of all these issues. So there are no issues in ETABS. Any design issue I could not find when it comes to AISC 360. So if you are, let's say, using AISC 360 and you are designing a structure using STAD or ETABS, then I think ETABS is a better software than STAD. Uh, Only problem in AISC 360 when using ETABS is that it does not give you detailed output. So the detailed output for each member that ETABS gives you for AISC 360 is poorer than what STAT gives you. STAT gives you a very detailed calculation and detailed output for steel design as per AISC. Just hold on, give me a minute. Yeah, so I think this was a qualitative comparison between ETABS and STAT, and which is a better software. So long answer short, if you are using IS 800 2007, you have to be careful when using ETABS. If you are careful about and if you are aware of these issues, which ETABS has, I think ETABS is a better software for steel design. But if you see in the Indian context, you will notice that people use STAD more often than ETABS when it comes to steel design. There is no specific reason for that. The only reason I can think of is that STAD has been there before ETABS in India and abroad also. And because many old engineers by age, many senior engineers started their career or started designing using STAD, and maybe many of them did not switch to ETABS, so they are more comfortable with STAD. And because steel design, young engineers don't do much, I often find senior engineers more comfortable in doing steel design or involved in steel design more. Maybe that is the reason they are doing using STAT, because they were using STAT since long. So in the Indian context, maybe STAT is the preferred tool when it comes to steel design. But I think I have explained, and my opinion, ETABS is better, provided you know the shortfalls or you know the problems with ETABS. Okay, all right. So this was this question that was asked by Mr. Harish Acharya from Bengaluru. Now Mr. Oves is joining from Srinagar. He is a working professional. He is asking which is what is the best way to model and design a building, and this is an interesting query. With an expansion joint in ETABS using a single model with appropriate separation or different models. And if a single model is used, how will it affect time period calculation? If using separate models, how can I consolidate reactions? So very interesting point. And incidentally or coincidentally, what Mr. Oves is asking from Srinagar, same question was asked by Mr. Arek Katual from Kathmandu. So he had asked three queries, but first his first question and what Mr. Oves is asking are same queries. So what I will do is let's club these two questions together and let's try to answer these two. Okay. So this is a question that has been asked before also by other engineers on personal WhatsApp chat or other forums. So I think this problem is being faced by many of you. So let me try to explain what procedure you can adopt, and it will involve procedure to be adopted for modeling multi, let's say multi tower project with a common raft. Okay. Has any one of you faced this problem before? Those who are joining us live right now, has anyone of you faced this problem that they had to do a uh, multi tower model? They had a multi tower model. Of course, if I'm calling it multi tower, it is separated by expansion joints or separated from each other, but it has a common raft. So what do you do in such cases? Has anyone faced this problem? Yes, Mr. Akash Babar is saying he has faced this problem. Okay, let us see what we can do in such cases. So, first thing, it will involve a lot of jugaad for this, and you should be good with these softwares like STAD and ETABS. Sorry, not STAD. Uh, you should be good with safe ETABS. You should be comfortable using the grids in ETABS, comfortable with the grid systems in ETABS, comfortable with interactive database editing in both these softwares. So let us see what I can think of as a probable approach. Mr. Arbaz Kazi is saying we export the joint loads. Now, where do you export the joint loads? Okay, let's see. So the process that comes to my mind, I'll just try to explain it to you. Okay. So maybe I'm drawing a plan. Let's say this is your tower one, and this is your tower two. I'm drawing the plan views, and this is your tower three, whatever. All these are plan views. Okay, and of course you had gaps between them, so there were three different models, and now you want to have a common raft for all these three. So the problem in this case is that let's say if I make a single ETABS model, if I make a single ETABS model, what will be the problem? Tell me. If I make a single ETABS model, what will be the problem? So in this case, the problem will be that if in the same model I make all these three things, okay, if in the same model I have these three buildings together, then dead load, live load is not a problem. Problem will be in the seismic calculation. Why in the seismic calculation? Because time period will be an issue. Okay. So as you know that time period, usually even now as per the IS 16700, we are allowed to use the time period as calculated by the software, that is based on the basis of actual mass and stiffness. So time period calculation can be a problem even if, let's say, you are using the approximate time period formula. For example, in the Indian code for tall buildings, let's say the formula goes something like this. I may be wrong. I mean, I Don't remember the exact formula, but something like this: 0.0672 h to the power something. So what might happen, that let's say these three may get different time periods. Okay, so it's quite possible that because of the different heights of these towers, you might get different time periods. So the problem is how to apply seismic load in such cases. You getting my point? Or even if let's say you are doing response spectrum analysis, now if you do a response spectrum analysis, how will you ensure that response spectrum is carried out for these three models separately in a proper manner? So that is an issue. So what you can do in such a case is, what you can do in such a case is that, again, this is my thought. First thing, you make a combined grid system to start with. Okay, you make a combined grid system to start with, and then make a combined model also. So first thing, make a combined model. Okay, make a combined model. This is your step one. Make a combined model in ETABS. When I say combined, that means all the three buildings are modeled together on a same grid system, on a consistent grid system, that is, with whatever separation gaps you want to have. Model them all in a combined model. This is your step one. In step two, maybe what you can do, you save as and make three separate models. Okay, so save as three separate models. Now while you are doing that, how do you do that? So let's say you had this main model, so you save it as T1, and in that you delete the other two, keeping the grid system same. Okay, so you delete like this, keeping the grid system same, and this becomes your model 1. You get my point? Then again you save under a different name. This time you delete this and keep the tower 2, and this gets saved as a different model. Okay, similarly for third tower. Are you getting my point what I'm saying? So keeping the same consistent grid systems, you do this work. I hope this much is clear. Something like this. Oh, sorry, this. Yeah, so this becomes my third. So in this manner, using the consistent grid systems, you make three separate models. So save as three separate models. Keep the consistent grid systems. So don't change the origin or don't change anything. Keep it as it is. Let it follow the consistent grid system. Then what you do, see, the problem is mainly for your the problem is mainly for seismic. For dead load, live load, anyway, we don't have much problem, whether we are doing it in a combined model or we are doing it in a separate model. So the main problem is for seismic. Even for winds, let's say if you have got your outputs from the wind tunnel report, you will anyway, the wind tunnel testing, when it is done on a combined system. So wind is also not a problem. The main problem is the seismic. So what we are doing is sort of applicable for the seismic issue. So now in the third step, what you do, you apply, let's say you apply the diaphragms, and after applying diaphragms, you diaphragm assignment, that is, so apply diaphragms and analyze individual models, individual models for earthquake, whatever, whether it is response spectrum or equivalent static, whatever it is, you assign, you analyze your structure, do the Bayesian scaling, this, that, whatever needs to be done, you do. And then what you do, once you do this, you will get what are called as the story level forces. So you see the you take the story level forces. So story level forces will be generated for each floor in these three separate models. My writing is not so poor, but I think I don't know why this writing is coming so poor. Anyway, so you get my point what I'm saying. So in the individual models, you analyze it for the equivalent static or response vector, whatever. Once you do the analysis, then in ETABS you can display the story level forces, or you can also get the diaphragm level forces. Okay. Now what you do? Now you go back to your original model, and so copy the seismic story level forces and paste it to individual diaphragms in the main model. Did you get my point? So this is again possible by using the interactive database editing. So in this case, what you will need to do is, let's say this is my main model. You can put this diaphragm assignment, let's say D1, let this assignment be D2, let this assignment be D3. Okay. So all are different diaphragm assignments. Then you will be able to take the forces from individual models and paste it over here using the interactive database editing option. Do you understand what I just said? So now what you have the main model, and in the main model you have all the outputs. Sorry, you have all the load assignment complete. So the problem was mainly with the earthquake load. We have sort of put this jugaad to take care of the earthquake loads or seismic loads. Now it's quite easy. Now you have the integrated model with all the load assignments. You analyze it, and then you can export it to safe. Did you get this? Did you get this method? What I just explained. This is one of the ways. Did you understand? Hello. There can be another way. There can be another way. So let's call this as my method one. Now let's see what can another method be. So in another method, what you do is you have already made these separate ETABS models, keeping the consistent grids. So you analyze them independently. So you have three separate models. You analyze them and design them independently. Okay. Now what you do? So you have three separate models, uh, three separate models you already have. Now you go to save. Okay. Now you go to save. In safe, now what you will have to do? So let's say in safe, you bring your consistent grid. So this is my consistent grid. Now using the interactive database editing options, you will need to bring the reactions for tower 1. Okay. In the same model, you will have to bring the reactions for tower 2. And in the same model, you will have to bring the reactions for tower 3. This will be done using the interactive database editing option. I think this is what Mr. Akash is saying. Instead of this, prepare three tabs model and three separate safe models. Finally, club safe model into one. Yeah. So then using interactive database editing options, uh, you have one, let's say master save file. Okay. And you have three separate save files with consistent grids. And once you get the load reactions, once you have these reactions with you, then using the interactive database editing, you can integrate these three files into one using the interactive database editing option. That is another way. But doing that, and I think in that what you can do, it's a simple control C, control V. I don't know if you have ever tried it or not, but let's say you have a consistent grid already there with you. Okay. So you go to a model where only this raft is there. You just copy this and come to this master model, just paste. So automatically it gets pasted at the desired location. Similarly, you go to this individual safe model, you just control C, come to this model, control V. It will get pasted at your desired location, provided that you have followed a consistent grid. So you can do this also. Okay. So both these options are there, but both will involve a lot of jugaad. So you see which option is suitable to you. You can use that, but it will definitely require that you follow a consistent grid system. Don't try to change the origin. Keep the origin whatever it was for the consistent grid, master grid. Do independent modeling, independent analysis. Then either you can integrate in safe later on, or you can do this work where you just analyze it for earthquake forces and then bring the earthquake forces to your master model and then take the master model to safe. Whatever suits you, you can adopt that approach. All joint labels, yeah, that is also another problem. All joint labels must be different. That's why I'm saying make a master ETABS model first, then save it into three separate models so that the joint labels will be different there. You get my point? Yeah. Okay, so this was the question asked by Mr. Oves, and this was also asked by Mr. Alek, and this has repeatedly been asked by others also. So I think you can try this out. These two methods you try to do some jugaad. I hope you will be able to do it. Next question is, so there are three questions from Mr. Akash Babar. He is joining from Mumbai and he is a working professional. So he is saying, first question is how to handle soft story failure in buildings with open parking floors on ground. So this is quite a common problem that we come across, that in many of the residential buildings you will come across this problem of open parking levels, and because of that there is a significant reduction in the stiffness, because of which it becomes a soft story. So in such cases what needs to be done? So there is a clause, soft story at parking levels. So in IS 1893 they have specially addressed this issue. So let me just try to open the PDF for 1893, and there is a special section, I think section 7 point something, 7.10, where it tries to address this issue. So let's see what it has to tell us. I'll just go to 1893. I hope you are able to see it. So this section says RC frame buildings with open stories. Okay. So this is precisely what is being asked. So RC movement frame buildings which have open stories at any level. Uh, just a minute. Tools. No, I just want to have my pen tool. Just give me a minute. Pen. That pen option is not coming. Anyway, so RC movement frame buildings which have open stories, uh, such as due to discontinuation of masonry walls. So this is precisely what happens in the parking floors. Discontinuation of unreinforced masonry walls are known to have flexible and weak stories as per table 6. Table 6 is the table for vertical irregularity. So in such buildings, suitable measures shall be adopted in order to increase both the stiffness and strength at the required level in the open story. So what are the measures they are saying? Either you provide RCC structural walls or you provide braced frames in these bays. So both these things may not be practically possible for you to provide braced bays in open stories. So mostly what will be more suitable is to introduce maybe some additional RCC structural walls at this level. Now when you are going to provide RCC structural walls, they should be yeah, that's okay, founded on properly designed foundations, continuous, preferably over the full height. Now this may be possible, may not be possible, that you have a wall system which you are going to continue in the parking floor and which is continued at the upper levels also. This is preferable, this is not compulsory. So you may have it, you may not have it. Important things over here is and connected preferably to the movement resisting frame. So wherever you have introduced walls, you try to introduce some beams also which will connect it to the existing movement resisting frame. So when you are going to provide walls, they shall be designed in such a way or they should be configured in such a way that the building does not have additional torsional irregularity. So addition of walls should not introduce additional torsional irregularity. Okay, so you have to be careful where you are introducing walls, RCC structural walls. Wherever you are introducing walls, the lateral stiffness should not be less than 80% of the story above. Okay, and the strength should not be less than 90% of the story above. Also, when you are introducing walls, try and have a wall density of at least 2%. Structural plan wall density means structural wall plan density means out of the total plan area, at least 2% plan area should be of the RCC walls. So try to have them in both directions. So these are the, I mean, if you ask what code is telling you, code is telling either you introduce RCC structural walls in the open story or you introduce braced frames in selected bays. So this is what the code requires you to do. So I think in mostly post the Gujarat earthquake at Bhuj, where we saw a lot of failures in these soft story open parking like buildings, people have introduced started introducing walls or wall like columns, especially at the open stories in their floor plans. Okay, so I have seen many buildings these days where they do try and have wall like columns, and mostly on the periphery they try and provide where the torsional irregularity is not introduced or plant torsion is not introduced. Okay, so braced bays I have not seen much being provided practically in buildings, that providing X bracings or providing eccentric bracings. I have not seen in Indian context, but in the countries outside India, I have seen some images where they do introduce braced bays at the open story levels. So this is what your code has to tell you. And this was his first question by Mr. Akash. Next question, he's saying the one-way shear check. Just a minute, I'll just copy all these doubts and paste it over here. Yeah, so next question is what to do in case of one-way shear check when the when effective distance of two adjacent columns overlap and there is a sketch that has been provided. I have downloaded that sketch, so let me just bring that sketch over here. Okay, so is this sketch visible? So I think this question that has been asked by Mr. Akash Babar, many of you may also have a similar doubt, and it's a doubt that we do have all. I mean, many of you may be having, or you might have already faced such an issue. So let's see what he's saying. So this is your raft or footing, whatever combined footing. It's 1200, and small d is 1140 as per the image. So now if you see for this column, there is this column and then there is this wall, RCC core wall, whatever. Now for this column, if you see the d distance lies outside the footing. So the critical section for one way shear lies over here. So if such a thing happens, what does it physically mean? Tell me. What does it physically indicate if such a thing happens, that the critical section is lying outside the footing extent? If I were to draw a section, what's happening over here? That this is my column, this is my raft. So the critical section, if I draw, it is lying outside the footing extent. So what does that mean? This means that my column over here is able to provide the shear resistance, because whatever shear force will come, it is directly in the 30-degree, or it is within the plane of the column. Not plane, what should I use the word? It is within the reach of the column. That means there will be no actual shear, or whatever shear is generated, it will directly get transferred to column through a deep beam or a truss action, and it transfers to column as an axial load. So in this raft is not critical for shear. So I'll say raft not critical for shear in this region, because the critical section lies outside the footing. That is the first thing. Is that clear so far? Okay. Now the next situation, what he is saying, in the next situation, what's happening, that two elements are so close to each other that their d distance regions are overlapping. So this also you might have, this type of a situation you also might have faced, that I have two elements which are quite close to each other. Now what's happening, if I draw a d distance away, it lies over here for this column 1. If for the column 2 I draw a d distance away, it's lying over here. Now in such cases, what do you need to do? Hello. In such cases, what do you need to do? So in such a case, what you can do is that first of all, you find out what is shear in this region. Let's say if you had to find out shear over here, you find out the shear, whatever it was, and maybe in a software or using hand calculations, you will get to know the shear in this region. So whatever is the shear force diagram, uh, that shear force diagram you will get. Maybe your shear force diagram is something like this. Uh, so whatever happens over here, whatever. So first of all, you get the shear in this region. Now once you get the shear in this region, once you have the shear force in this region, what you can do is you can use the concept of shear enhancement. So shear enhancement means we are allowed to increase the tau c value in sections which are near to support. How many of you know it? So for example, I have to check the shear at this location which is quite close to this C2, and it is within the it is nearer to the C2 column. So in such a case, whatever is the shear force, if it is near to C2, if it is within the d distance from C2, I am actually allowed to enhance the tau C value in this region, and these clauses or these provisions are given in IS 456 under section 40.6, I guess. So if I were to show you those provisions, so they say, and I have kept them ready. So 40.5, enhance shear strength of sections close to supports. So basically what it is telling us, that if the section over here, I'm not able to use my pen. Wait a minute. Arre. Somehow that option for writing on the PDF is not coming today. Anyway, so this section is close to my support. It is at a distance AV. Okay. So I am allowed to increase the tau C value in this region by this 2D upon AV factor. So code allows me that if your section was quite close to a face of a support, uh, if you want to check tau C over there, you're allowed to increase the tau C value by 2D upon AV. So you can use that option in such cases. So maybe if I was checking shear over here, because it was quite close to this C2, let's say this distance was AV and this depth was D. So whatever shear is here, I check it against tau C into BD. But in this case, I am allowed to enhance the tau C by this factor 2D upon AV. Okay. So in such a way, I can check these sections where the D distance from one of the columns is within the critical, or it is within the vicinity of other support. Is that clear? Yeah. So I think this is the way you can tackle this issue. His next question was, Mr. Akash was asking, next question, is modal participation clause mandatory when following equivalent static method? Now, what is this modal participation clause, by the way? I'm not sure. What is this modal participation clause means? Hello. If you are attending it live, what do you mean by this modal participation clause? That 90%? Can someone try and explain? I think by modal participation clause he means, although I'm not sure, I guess he means the 90%. No, but that should. I'm not sure with the modal participation clause. Anyway, simple answer I would like to give is that in our IS 1893, we are restricted to use the equivalent static method only for there is a special, I mean, only under specific criteria are we allowed to use IS 189, are we allowed to use the equivalent static. Otherwise, our code wants us to use the response spectrum method always. What are those special provisions, or under what conditions are we allowed to use equivalent static? So I guess the code tells you buildings in zone 3 not more than 15 meters height, you may go with equivalent static. Otherwise, any building in zone 4 or zone 5, you have to go for response spectrum, if I remember correctly. Let me just check. So if that is the norm, or if that is the requirement, For smaller structures, you will see that it is mainly having a behavior which is closer to the equivalent static behavior. You understand? That means the top floors are deforming the highest in a parabolic manner, followed by the lowest floors. So you will notice that if you are restricted by this condition of the code, that only till 15 meters height, and that too in zone 3 and less, you're allowed to use equivalent static. Otherwise, for all other zones, zone 4, zone 3, greater than 15 meters, zone 4, zone 5, if you are required to use the equivalent response spectrum anyway, I think this issue related to mass participation, or this issue related to uh, other dynamic mode shapes may not be a real issue as such. You understand? So for, I was just trying to search and I'm not getting that clause. If I share 1893 at the location where it has given us, yeah. So if you see this linear dynamic analysis for all buildings other than regular buildings lower than 15 meter, or seismic zone 2. So that means as long as your building is less than 15 meters in zone 2, you can use equivalent static. Otherwise, for all buildings which are greater than 15 meters in zone 2, and for all buildings in zone 3, 4, and 5, you are mandated to use the response spectrum method. Okay. So the question of equivalent static method will not come if you are in zone 3, 4, or 5, or if you are in zone 2 and building height is greater than 15 meters. So now what I'm trying to explain you is that for such a short height, and for such a low seismic zone, the behavior you will observe of the structure will be closer to equivalent static anyway. Okay, so it will be mostly a parabolic uh, deformation behavior that you get from a equivalent static approach. So there is the question of other modes, or the question of modal participation, or the other questions don't appear anyway. Okay, and if you are getting some irregular modes, let's say you are doing a building which is in zone 2, but it is 10 meters and it is highly irregular. So anyway, if your if your model behavior does not show a behavior which is close to equivalent static, if you are failing as per table 5 and table 6 requirements, anyway you will again have to go to response spectrum. So you get my point? Okay, so to summarize, what I mean to say is, as long as, let's say, you are in zone 2 greater than 15 meters, and all structures in zone 3, 4, and 5, if that is your case, you have to go for response spectrum. There is no question of equivalent static. Let's say your building was in zone 2 less than 15 meters, then you check the model behavior. You just check the first three modes, see if you are getting proper translational modes, torsional modes or not. You see if you are having any vertical or horizontal irregularity as per table 5, table 6. If not, you go with ESM. If there is any irregularity, or if you are getting improper model behavior, again you go to response spectrum. Understand? Yes. Okay. So I think you got what I'm trying to explain. Okay, so these were the questions asked by Mr. Akash. Now we go to next question, which is asked by Mr. Alek. Mr. Alek Kadwal from Kathmandu, Nepal. He's a working professional. His first question was the same that Mr. Oves had asked, so that has been answered. Now his next question is, many times shear wall joining column fails. shear wall joining column. I think he had shared one image also. Let me see. Okay, so I have the image, and let me share the screen. Yeah, so he had shared this image, and let's copy all his doubts also. Okay, so first question we have already answered. Way to merge ETABS model. So this is done. Now he's saying many times the shear wall joining the column fails. What are the solutions? Now, so I think you had shared that screenshot also, and your shear walls were failing in the point 4 FCK check. So you need to go to IS 13920 now, and you will see that there is a check for IS 13920.4 FCK stress not being exceeded. So that has to be uh, satisfied. So see what will happen in the vicinity of shear wall anyway, because of the large stiffness, it will attract large movement, and maybe therefore these columns which are in the vicinity of the shear wall, they will start showing you failures because they are near the shear wall which is attracting. I mean, you have made the node common, so they will attract a lot of very high axial forces under the seismic loads. So that is the reason they might be showing you failure, and that point 0.4 FCK clause is being exceeded. So my suggestion is don't have these columns where you already have a shear wall. There's no reason for that. If you have a shear wall, the shear wall is acting as a column also. Understand? So don't model a column separately. Just have your shear wall over here and here. And anyway, we are going to detail the ends of this shear wall as boundary element. Okay. So my suggestion to you is don't model these columns, uh, and let the shear wall be as it is, because if you are modeling the column over there, uh, it is because of the high stiffness of shear wall, it is attracting large movements, and therefore your column is getting very heavy axial loads, and that is one of the reasons why it is showing you failure, mainly under this point 0.4 FCK clause of 13920. So you remove the columns, keep only the walls, and if framing is an issue, as Mr. Akash is saying, remove the column elements and rest the beam on shear wall. Now if you are afraid of, or if you have a problem with the node over there, you can divide the shear wall in such a way that you get the node at desired location. Of course, over here you are already getting a node over here. Maybe under some condition you had a beam over here and you did not get a node in the wall. So you divide the shear wall in such a way that you get a node over there. Understand? So don't have columns in this vicinity. It will have you in problem. So just remove these columns. Let there only be shear wall. Okay. Then the next question is a 200 seismic gap normal for 4 stories building? I mean, I don't know. Without checking the calculations and without being sure of the seismic zones, Nepal may be in the highest seismic zone if we talk in the Indian context, so maybe in zone 5. So unless we have the data, difficult to predict. Okay. Again, it depends that, see, what will happen that let's say you had a building like this. So you had some podium levels and then you had a offset tower. Now when you have to go provide a gap over here, seismic gap, of course that will be dependent on the deflections at this level. Yeah. But if you have a tower like this and without having any offset, of course I'm showing you the elevation. Now these are two towers without having any offset. Now this time the gap has to be calculated as per the top story deflection. So it will depend on the configuration that you are having. Whether 200 is a large gap or a small gap, I am unable to comment unless we have some data points in front of us. Okay. So that was the question asked by Mr. Alek. Let's see what else do we have. Next question is being asked by Mr. Farhan Danish. He is joining from Aurangabad. He is an independent consultant and he is saying in some projects seismic analysis is avoided. That is, they tell not to do seismic design. In such a case, what to do? So, in such a case, see what we do personally. For example, where we live, we are in seismic zone 2 with not a realistic chance of earthquake as such. Uh, we are in between seismic zone 2 and 3 actually. So, if you see as per the code, they will tell you to, if you see as per the seismic code, they will require you to do the design, tactile design that is. So you will have to apply IS 1893 and you will have to apply 13920 design and detailing provisions both. So by design provisions, I mean that for you will have to consider the beam column capacity ratio, you will have to consider the joint shear check, you will have to take BC as 0 for beam shear design. So all these are design provisions. So you are required to do all these things. Now practically what we do generally for small structures in zone 2 or zone 3 also, if they are small, that is G plus 1, G plus 2, G plus 3 stories, and where we know that earthquake is not a real problem because we are in such a location that we realistically don't expect earthquake to strike. So what we do usually is we will follow 1893, we'll apply the seismic forces, and then we'll just follow the detailing principles. So by detailing principles, I mean that we will follow the close stirrup spacing criteria, will give the confinement reinforcement, we will give the close shear stirrups at the ends of column and beam. So we'll only follow the detailing rules, but we will not then check the beam column capacity ratio, or will not do the joint shear design, or will not take VC as 0 for shear calculations. So design provisions will not take, we'll only take the detailing rules and we'll just apply a simple earthquake load. That's it. Let's say if you want to even ignore this, still what my suggestion is, just follow the detailing rules. That means have the 135-degree hook, have the, as I just said, have the confinement reinforcement provided, have the closely spaced stirrups. If you do only these things, that is more than enough in a zone 2, zone 3 building, which is small G plus 2, G plus 3 in a lower seismic zone without much irregularities. It is more than enough just to follow the detailing rules as per 13920. This is what we mostly do. If we just don't want to even apply 1893, I think following the detailing rules is good enough. Okay, so that is my practical suggestion what you can do. So these were the questions that were asked for this week on the Google form. So we have finished off the questions in the Google form now. If anyone of you has any question, they may ask in the live comments. So anyone having any question? Yes, please. We have completed the questions in the Google form. So anyone having any queries, they can put it up in the live comments. Oh, there was one question. Sorry. So Mr. Rohit Patel is asking, will AI disrupt structural designing? I mean, it can, because anyway you are doing the designing See, it can disrupt the mathematical calculations that it can do maybe in the next 2 3 years, because you are using calculations. And if, let's say, the AI agents are able to integrate, so let's say if you are able to integrate the chat gpt and etabs together, okay, or if you are able to integrate chat gpt and stat together, so whatever you are doing, let's say you are doing the modeling on your own, then you are assigning loads, maybe that thing can be taken by an AI agent. I don't see that to be a very difficult scenario. But then the real structural engineering also involves thinking about the structural system, or coordinating with the client, or coming up with a solution as per the site conditions. So maybe that process AI agents will not be able to take over so easily, because it involves a lot of communication and a lot of coordination. So maybe that is difficult to be taken over so quickly in the near future. But as long as simple mathematical calculations are involved, that I think can be easily taken over if an AI agent is integrated with a software like ETABS or STAT. That can happen. But then that is a very small part of your overall job as a structural engineer. So overall job requires a lot of other issues than just mathematical calculations, isn't it? So that portion of your job is hard to be taken over as of now. The mathematical calculation part can easily be taken over. I don't see any problem with that. Yes. Okay. Anything else? All right. So I think we don't have any other questions in the comments. We also don't have any uh, question in the Google form. So I think that's it for this week then. We'll see you on next Saturday, that is, with the next session of Ask AuxEn Anything. Till then, have a good time and have a good weekend. Thank you.